Hi, welcome back for another 6 Caillou challenge called Ka Cypher, Words Only Volume 1. This cipher is used by small children in some country when a girl wants to pass something to the other girls and there are some boys nearby, she can use a Ka cipher. And so basically they interject these Ka words, if you will, in between characters in the sentence. It looks like they follow vowels. We'll go over the rules here. The encoded word should start from Ka, and then the Ka goes after every vowel. When there is multiple vowels together, the Ka goes only after the last vowel. When the word is finished by a vowel, do not add the Ka after. The word consists of only lowercase and uppercase characters. There is only one word to convert, no white spaces. Okay, so these examples are helpful. You got the letter A. Remember, you always start with Ka, so that's where that comes from, and then you just have the A. And remember, you don't get a second Ka because you don't do it when it ends in a vowel. But notice Ka, so you start with Ka, and then you add the word Ka, so you get Ka. Then you have Aa, you start with Ka, and then it's all vowels, right? So you just keep going until there's no vowels anymore. But in this case, it hits the end of the word, right? So we don't put Ka at the end of words. So that's why it's just Aa. You've got Abba here. Note you start with Ka as always. And then the A, immediately after the A, right? You hit a consonant there, B. You inject the Ka, and then it continues BBAA. Maintenance, you got Ka, MAI. You have two vowels there, right? AI, so you wait till the vowels are done. It ended on the I, so you inject the Ka. Then you continue with maintenance, NTE, inject another one, NA, inject another one, NCE, and you don't put one after the E because it's at the end of the sentence. And you can keep going through the rest of these. I think I did enough to make it clear. So I think that's it here. Go ahead and pause the video, think about this, go through it. I'm going to show you a few different ways of doing this. I'm just going to use a basic for loop and kind of build a string result to show you that sort of basic way. And I am going to make sure I get you a solution with regular expressions too. Maybe even I'll throw in a LINQ in there. The LINQ's going to be a lot like what I do with the looping, where the select statement kind of fills in for the for loop. But let's start simple and just go to work, right? Let's build something. So to start, let's see. Let's use basic building blocks here. So I'm going to have a result. You could use string builder. I'm just going to use a regular string here. I'll say string, call it result. And you know what? I'm just going to initialize it with Ka, because remember it said that you always start with that. So we'll just build on top of that. Might as well initialize with that. Then a typical for loop, int I equals 0. Nothing fancy here. I is less than word.length. Increment I. Let's define some scope for our for loop. So just, in other words, we're going to iterate over all the characters in the word. Let's start by sort of caching the current letter. And so that would clearly be word at index I, right? We can think of a string as an array of characters, and we're just using these square brackets to index into the word. I think you're good with that at 6 Caillou. So then we have a couple cases, right? We're either dealing with a vowel or a consonant. So what I want to do is something like this. If is vowel, and I can check the letter, right? But obviously is vowel isn't a thing. And then else, if it's a consonant, we're going to do something else. So let's go ahead. I'm going to make this helper method, private static. I'm making it static because I don't need to create any objects to use this. It's just going to be something that takes a character in and tells you if it's a vowel or not. So there's no need to instantiate a kata or a kakodakami or any other kind of class, right? So I'll say returns a bool, right? If true or false, is vowel. And it's going to take a letter in. And maybe I'll use this alternative syntax here, this shorthand, just to mix it up. You can write this out as with the curly braces if you want a standard function, how we're used to seeing them. But I thought I'd mix it up. This is about learning, right? So is vowel, how can we say this? We could say array exists. I know we've seen that in a solution. I don't know if we've used it in a challenge before, but why not now? It's as good a time as any. And it's just like it sounds like. It's going to check an array, some collection, well, an array specifically, because we're invoking this from the array class. And it's going to tell us if a predicate is met on the elements in the array. So let me actually pull this up for you. Here we go. Array exists. Determines whether the specified array contains elements that match the conditions defined by the specified predicate. Predicate's just a fancy word that tells you if something is true or false. So let's see if we can get you an example here. Before we do that, note, it takes in an array. They use the generic type T, meaning it can be integers, strings, characters, whatever you're working with, a custom class, and then this predicate. And we're just going to use a lambda expression for our predicate that will tell us if the character matches what we're looking for or not. So if we can get you an example here, notice these array exists. You had this array already created of all the planets. And so they're saying array exists. You drop your array in, and then you give it the predicate. Remember, we've worked with lambdas a lot now, so you give it your parameter name, element, which applies to each thing in planets. I would have called mine planet personally. And then do whatever logic you want to do. So in our case, we're going to check if it's a vowel, but this is the syntax we're going to use here. You could even copy that if you wanted. So let's go back. Array exists, and I got to give it an array. I'm going to just make one in place here, a new char array. Use the curly braces just to initialize it right here. I'll say A, E, I, O, oops. Remember, it's a character array, so I'm using single quotes. So I got my array, and then the other part was the predicate, right? So you give it, this is where we get to drop our lambda expression in. I like to use ch as my variable name to describe characters. And then I'll say ch is equal to, I think we've used this in other challenges, char to lower letter. And let me actually, this is kind of running off the screen here. I'll do this just so you can see it. And by the way, I should probably be blowing this up for you. Okay, so now we have this handy method here. I'll just tell us if a letter is a vowel or not. Yeah, and so we're just doing it to lower because I put only lowercase letters in my vowel collection. I could not use to lower, but then I'd have to put capital A, capital E, capital I. So I just did that to shorten it, that's all. So yeah, we got two conditions here, is a vowel or it's not. So what do you say, should we handle the easy case first? That would be if it's not a vowel, in which case we're just going to add the letter to the result. Result plus equals the letter. Whenever you hit a consonant, just add it, right? So that's a trivial case. When it's a vowel, it's not hard, we just have a little more work to do. We're gonna make sure that we don't just automatically insert a ka every time we hit a vowel, right? Because remember, you could have a chain of vowels in a row, and you're not supposed to insert kas after every one. You do it after the last vowel in the chain, and provided that doesn't end the word. So let's kind of express that in code. What I'm going to do is I'm going to first check if I is less than word length minus 1, which means we're not on the last character, right? It means we can look ahead at least one more. And I'm going to do that. I'm going to look ahead, and I'm going to say is vowel word I plus 1, and that's safe to do because I enforce this condition first, that we're lower in the index than the last character. So if that's the case, it means we can look ahead. So let's look ahead and see if we're dealing with a vowel or not. Or we did with that second part of the clause there, right? So if it is a vowel, what we want to do is kind of like with a consonant, right? It's a vowel, but we're just going to add it because it's not the point where we add the ka in. So we'll just say result, add the letter, and then, yeah, that's fine. And so then the other case that we could have here is we should, if we have a vowel, we have to address this situation where the ka has to be inserted, right? So what I'll do is I'll say if, kind of like I did before, if I is less than word length minus 1, which is another, it's just a way of saying that we're not at the end of the word, right? Which means it's safe to add the ka. So what we do is we want to include the vowel itself. Oops, I forgot plus equals. Letter plus ka. Good. And then otherwise, if that previous condition is not true, it means we're on the last letter. And so just add it. Even if it's a vowel, right? We don't add the ka at the end. So something like this, I think, covers us, unless I missed something there. We'll find out when we run it, right? So let's, you can imagine after, assuming we've processed everything right, then it's just a matter of simply returning the result. So I'll get out of here. Do an initial test run here. So I missed a semicolon on line 33, maybe? Yeah, sure did. The name array does not exist in the current context, so when that happens, you go to the class you are working with. In the system namespace, so let's go ahead and bring that in. Ooh, I don't like that extra space there. Don't mess with my OCD. Using system. Good. Test again. Good. We'll hit the full collection here. And we nailed it. So you can go ahead and submit like this if you like. I'm going to show you the extra methods. This is just showing you, hey, you don't need anything fancy here. You can do this with your basic building blocks. But we're going to expand on that just because that's what we do here. We learn, we teach, we share. So let's go. I'm going to bring in system LINQ. I'll just show you because it's so close to this. I'm not even saying the LINQ solution is an improvement. In fact, I'd probably just submit mine like this instead of it. But I just want you to kind of make the connection between running through a for loop and using like a LINQ select statement. So why don't we do that? LINQ select. So what I'll do is basically we're going to rip the same logic that we have now. Let's do that. We'll say word select. I'll go ahead and comment this out, though we're going to steal some of basically the guts of the for loop is what we're going to steal. Okay, select. Remember, select projects each element of the collection into a new sequence. So for my select statement, I like to use, and because I'm kind of modeling this after the for loop, I want this index value, right? We were using it to look ahead in the collection. So I'm using that specific overload of select. I know we don't use it as much, but I'm going to use it here where you get to access the index value associated with each element as well. So I've got word select, and I've got each character as they come, and I get its corresponding index. And so I can basically do the same thing as like we did in the other one. I'm going to leave is vowel here because I'm still going to use this. So let me just define some scope for us. Word select, I'll do, it's basically going to copy this. Let's say if is vowel letter. If that was the case, then we just want to return the, well, that was the non-trivial case. So we'll handle this one, and then we'll handle, I don't need the else. So I'll say, if it is a vowel, let's do that look ahead thing. If copy that, paste that. If this is the case, then we just wanted to add the letter, right? So I'll just say return the character. That's going to, remember, that's going to put it in the output collection with, remember, select returns an IEnumerable of whatever type we're projecting into. And I'm actually, for ease of combining my result, I'm actually going to make these into strings. And you'll see when I package that up, notice the final result has to be a string. So I'm going to say this to string, and then, okay, then we've got the other case where if I is less than word.length -1. No, this is still the case where it's a vowel, right? We'll say return character to string plus the ka, right? It means we have a vowel and we have room to insert the ka. And then otherwise, we just return the character to string. Hopefully you can see the correlation. We're just not using the else's. We don't need them here. So, and then finally, if it isn't a vowel, it's just simply a consonant, and we should be able to just hit to string. But I hope you can see the parallel between, I mean, it's basically the same thing, just worded a little differently. So that's good. Like I said, we have this problem where select is going to return an IEnumerable, and it's going to be of type string, right? Because everything we're returning in here is a string. And so how do you make a string out of an IEnumerable of string? This is a common little idiom I use in this series. I use string join, and I don't want any gaps there. I add this. I'm going to have to add a closing parenthesis for this join thing. We just wrapped up the whole statement we wrote. But you probably agree, the lambda here is a little more complicated. It's not as nice looking. It really isn't that much of an improvement on the loop I just made. So I wouldn't even bother with this. I'm just trying to show you how to visualize that looping as happening with LINQ2. So let's see if I even typed this right. Okay, letter does not exist in the current context. Oh, sure. Yeah, letter I copied from the loop before. We called our letter CH now, right? I certainly does not exist. And remember, we called the I index now. It's totally valid. Suppose I could have renamed it to I. Did I get them all? And then we have an error. So my logic must have messed up. And is vowel trying character. That seems right. Plus ka. Oh, you know what we forgot to do? We forgot to add the initial ka. Sorry about that. Good. Good. So again, nothing special there. I just wanted you to see how you can hopefully train your brain to, go into whatever mode you want. LINQ mode, looping mode, same kind of difference. So what I'm going to do now is I'm going to clear all of these out. And what I'm going to end with is the regular expression solution. So let's do that. So I'm going to use regex matches for this. And I think I have that pulled up here for you. Regex matches, regular expression matches. Notice I'm under regex, under its methods, and you'll find matches if you want to check this out too. It searches an input string for all occurrences of a regular expression and returns all the matches. That's kind of what we want, but there's more to it than that. You get back this match collection, which has match objects. And so the point I want to make, maybe I'll show you an example first. Yeah, this is a good example. So notice how they're calling regex matches. You give it your input. Ours is called word. You give it a pattern to match. We're going to make that up. It's going to be basically looking for vowels, the last vowel. And then you get these match objects back that have these properties value and index. And look at this. They show you what was matched. notes in this case, and they tell you where in the string it was matched. So this is going to be helpful for us. We can use these positions, this index field of the match, to insert the cause where we want them and get our final output. So let's do something like that. Back to my challenge. We can say, let's make that pattern first. Mine's going to be a little ugly, but it's going to be easy to understand. String pattern, and what I'm going to do is I'm going to make some vowels. So if you're looking for letters, you could just type them out, and I'm going to put capitals in here as well. So either case will match. So right now I'm just looking for vowels. We know in theory this isn't good enough, right? Because if a vowel's at the end of the word, we don't want to match that. And what I'm going to do is I'm going to put this plus sign, which just means you can match one or more of these. So it could be 5 vowels in a row, it could be 2 in a row, it could be just one. All right. And then the other requirement I'm going to have is I want it to be followed by at least one consonant, right? And that's how I'm going to make sure that I'm not landing on the end of the word and inserting a KA there. So this will be a little ugly, but I'm just going to do the same thing and type out the consonants. So B, C, D, F, G, H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z, and then I'll just capitalize them to H, J, K, L, M, N, P, Q, R, S, T, V, W, X, Y, Z. Pretty ugly, right? And then I'm going to require that it has one of those. And then, so this is the pattern I'm going to match. It can match multiple times, right? That's why I'm calling matches and not just match, which would give us just one. So that's our pattern. And then once we have that, we already have our input. So we can say, remember, it returned a match collection. I'll call it matches. And then it will be rejects matches, just like what we had. It'll be word and pattern. We're going to keep this simple. I don't need any options. And then we're going to go through the matches and insert the KAs where we need them. So a couple of things to do here. I'm additionally going to add and you could do this on the same line as string if you want. I'm just going to say input. I'm going to set it to word because I'm going to modify this as I'm inserting the KAs in. And then I'm going to put int, let's put cause inserted. And this is going to help me with my indexing. In fact, maybe I'll leave this part out just so you can see how it fails and why we need it. But I'll just put it up there as a provision. And then the idea is for each match and matches, for each of those matches, we're going to cover them and insert our values where necessary. So one thing I want to do, let me help you visualize this. Control right line, and I'm just going to show you the current word that we're on. So I'll just say word, and then for each match right now, let's say console right line, and let's say val is match.value and index is match.index. Remember, just like the sample we saw on the document page. And so let me just return some gibberish. Return ka. Okay. Let's see if this will. Yeah, so what I didn't show you was using system text dot regular expressions. That is relevant. Okay, input ka. So we forgot to put our. There were no matches. Let's just do this. Input a. So let's add ka plus our input, right? It's going to start with ka, and then we're going to add our input word. We're not currently modifying it yet, but maybe this will give you an idea. So here we hit the ABBA example that's you see down here. So this is good, right? We get to see our first match. We hit it. Matched on the A, but notice how it took the first consonant too, right? Because we said match any number of vowels chained together plus the next letter when it happens to be a consonant. So that's why we matched there. And that happened at index 0, which is at the very beginning of the input word. This is the word that you're passed, and that's why that capital A is at index 0. So what you could be thinking is that, oh, I should insert a KA at position 1, right? That'd be after the A, and that's exactly what they're looking for. So the idea would be then that you would do something like input equals input dot insert, and then you just got to figure out the index on where to insert. So you could say, because remember, we could have multiple matches, so we want cause inserted at all of them. Match index plus match value dot length minus 1. And remember, that's going to get us to the last letter. We want it. The last letter is going to be a consonant because of our pattern. And so I just had to go back from 1 there. Remember, we could have 5 A's and then a B. And that's why I'm basing it on the variables, the length there. So the index where the match starts and plus the length minus 1 should insert right before that consonant and right after the last vowel. That's the idea there. This isn't quite right, but I kind of wanted to show you how we build this. So insert, you give it a position, then you tell the content you want to insert, which will be a KA. Let's run this. It's not right, but I'm going to let you see. So see how with the word maintenance, we got through a bunch of tests. The next one's going to be this maintenance. And what it did was it put the KA after the I in maintenance. That was the last vowel, which is good. Then it hit N, and then it put a KA after the N when it shouldn't have, right? There's a T after the N that should have just been passed through. And basically what's happening is that we're inserting into input, but input doesn't have the cause in it. So the indexing isn't quite right. We've got to account for the previous KA, right? Remember, before this error, right, we had a previous vowel, and so we added a length of 2 more characters to the string. So when it goes to insert, everything's skewed. So the way you can get around this then is if we also account for these insertions, and that's why I sort of put this in. And so when after we insert a ka, we should be saying cause inserted, incrementing it. And that way, the next time we come through the for each loop and get down here, we could say, okay, this indexing is mostly right, but input changed, right, from the last time through the loop. So we need to account for that. So I'll also add cause inserted times 2 because there's 2 characters in ka, right? So for each time we insert, you basically get 2 more characters into the length. So that's how I kind of account for that. Let's see what this does. Green. And green is golden. So I'm going to stay with this. In fact, we don't even look at vowels anymore, so I'm going to clean this part up. I'll do one more expansion here in case it's helpful to see this. Using regular expressions, we shouldn't even need LINQ anymore. Let's get rid of that. Let's get rid of all these console statements. I wanted you to see how this output was being built. That looks good. Ka plus input. We got a couple blank lines here at the end I'll clean up. And then, yeah, so we made a pattern, not a pretty pattern. The vowels, the consonants, lower and upper. You can have any number of vowels in a row. That's fine. And then just once you hit a consonant, that sort of defines where the match should hit. We call for those matches. We take an input, and with our pattern that we want to match, it generates this collection of matches, very appropriately named there. We go through each of those matches, and we have to insert this KA after the appropriate matches, right? And we had to play a little bit with the insertion point because we're modifying the input with these extra KA symbols. And the matches had these convenient properties that we were able to use for the indexing and noting the length of the match, right? It could have had one vowel or 10. And then finally, make sure you start your answer with a ka per the rules and just add your input. So pretty simple. I know irregular expressions are weird, so I'm not trying to downplay that. But yeah, I'll go ahead and reattempt this. And when I pass, I'm going to, and of course, I bungled something here. What did I do? Line 20. Oh, I accidentally deleted one curly brace, didn't I? So that looks good. I'm going to submit and collect my honor points. And you could condense some of this too, right? If like they did in the example, if you wanted to not make this separate matches variable, you can play around with that. Otherwise, yeah. I think that was enough for this video. We went over 3 different ways to go about this. So this was a much smarter way, right? Use regex options, ignore case, then I didn't have to type all that garbage out. Or at least not twice. So definitely go through these and see what else you can learn from it. Looks like they have vowels here and possibly a negation of it. I'll have to look through some of the regular expression symbols too. I definitely don't know all of them. So I'm going to scan through this too. You do the same. You know where to find me if you have questions or comments. Otherwise, thank you for those likes and subs. I'll see you in another video.